This video is about solving quadratics by factoring. Most of the work involved in this section is factoring, and I do a better job of explaining factoring in other videos. There should be a link near this video so you can go back and revisit those other videos. Anyways, just some background information. We're dealing with the zero property of multiplication. No, that's not right. Is it? I don't know. Alright. The idea here is that if we know that A times B equals 0, the important part here being equal to 0, and that there are factors, A and B are factors of this expression, that one of them has to be 0. Either A equals 0 or B equals 0. And because of this, we can solve by factoring, but once we get the factors of a quadratic, then one of them must be equal to 0, and we set them both equal to 0, and those are the possible solutions. Well, if you didn't understand any of that, here are the mechanics. I'm going to do a couple problems from the worksheet. Okay. Let's see if we can zoom in here. Alright, here we go. Alright, number 1. First thing you want to do, remember the whole idea was based on factors equaling 0, the product of factors equaling 0. Well, that's not it. So what we got to do is move everything to one side. So I'm going to move the 7p squared over here. That'll be 21p squared. Move the 7p over. That'll be plus, what is that? 133, because I'm subtracting. Minus 280 equals 0. Alright, we're starting with the interesting one here. Okay, what I'm thinking through here is see if there's a common factor in all of these. I do believe there's a common factor of 7. Okay, what I'm going to do is divide the entire equation by 7. When we do that, I get 3p squared plus, then 7 goes to 133, 19 times. 40. Double checking though, 19 here. So, yeah, okay. Alright. Sorry. There is no other common factors. 19 is a prime. We can use the lazy method or trial and error. It's going to be 3p. P. 5 times 3 is 15. Oh, plus we gotta make it subtract to make 19. 10 is 34. Oh! Why? Okay, how about 8? 8 times 3 is 24. 8 times 5 is 40. 24 minus 5 is 19. So we want the 24 to have positive, so that's negative. Alright. So, once we got it factored, and that was using trial and error, that's... Anyway, set each factor equals 0, so it's 3p minus 5 equals 0, and p plus 8 equals 0. When we solve those, we get p equals 5/3, and p equals negative 8. So those are my solutions. Okay, that's basically how you do all of them. You set them equal to 0. Get rid of any common factors. Notice I didn't bother to write the common factor of 7. What I did was divide the entire equation by 7. This is a little different from just factoring in general. If I were just factoring in general, I have to leave the 7 with the problem. But because I'm solving it, as long as I'm only dividing by a constant and not a variable, I can just throw it away. Alright, so here we go. That's it. I guess I could do another one. I'm going to do number 3. If you want to pause the video and try it on your own, do that. Well, okay. Okay, number 3. Alright, move everything to the left. It'll give me 3n squared. Let me give myself a little more space here. 3n squared minus 10n plus 7 equals 0. Yeah, this one's a little easier. 3n. I'm not going to multiply. 7 plus 3 is 10, so that means don't multiply. Okay, So we got 7n plus 3n makes 10n. We want them to be negative. It's equal to 0. So you can set each factor equal to 0. You get n equals 7/3, n equals 1. In case you're getting lost on this step from 3n minus 7 equals 0 to n equals 7/3, I'll work it out over here. Keep in mind, this is just straightforward algebra. Just add 7 to both sides, give me 3n equals 7, then divide by 3. So that's where those fractions are coming from. Okay, so these are the possible answers. N equals 7/3 or n equals 1. Some teachers will be very particular on or, because n can't be both at the same time. Okay, that's the only example I'm going to do. The worksheet does come with answers, so you can go ahead and work them out and see if you get the same answers that are provided with the worksheet. Alright, bye.